Awesome. Cool. Hey, everybody. Welcome to the Spinnaker SUMMIT, and pleasure to be here. My name is Joel Vasallo. I'm going to be talking today about using Spinnaker as a platform, specifically in the industry that I work in today, healthcare. There's my Twitter and my details there. Don't worry, it'll be at the end too. So just a brief note of what Aspen Group is. Aspen Group is essentially made up of a bunch of smaller organizations, most importantly Aspen Dental, along with all the various partners that we have in Clear Choice Now for urgent care, and even things like vets. So it's kind of trying to become a one-stop shop, if you will, for healthcare. So it's actually a pretty cool space to work, and a lot of great engineering efforts going on there. So, back in 2019, we were tasked with the digital transformation. You know, we heard about it. I don't know about you all, but I keep seeing it on LinkedIn. The digital transformation, the cloud is your digital transformation. It's your highway to success, right? But let's be real, when you're starting off, sometimes it looks like a dirt road. You're like, okay, so much for that highway, right? Where do we go? How do we start this off? It's a lot to learn. So, 2019, a synopsis. Approvals, lengthy. Change control boards. Hey, I gotta go talk to somebody. Well, this team needs to approve it. A lot of changes and a lot of architectural decisions that need to be made. Rollouts. Those approvals only added time to rolling out your software. It was time consuming. And oftentimes, those changes were done off hours. Hands up whoever's done like a Sunday night deployment like 3 in the morning, because that's like the only time. Yeah. Verification, manual QA testing. It's great, but sure, boy, does it get old. And monitoring, you all have PagerDuty, right? Like, yeah, it's working? Cool. Our application architecture. You know, we had the dreams of, you know, you hear Microsoft talk about .NET Core, containers, the cloud. We're like, yeah, but we're still stuck in a monolith. We have this giant Windows app with, you know, it seems like it has like 900 APIs. It just keeps growing. So how do we kind of like go from there to what our dreams were? We just didn't have the technical expertise at the time, nor like the vision and direction on how to get there. So that's a spoiler. That's probably why this quote I saw the other day, that roughly 67% of 1,000 senior technology leaders say that they haven't seen a significant return on their cloud investment. And we were one of them. But I argue that a lot of folks just took their data center and tried to cram it into the cloud. And we all know how that goes, right? Whether it's cost effective, right? The cloud was never about being cost effective. It was about giving you capacity on demand such that it could produce the potential for cost effectiveness, right? If I only have 3 users visiting my website, do I need 50 servers? No, let's scale that nice and down. If I'm in an environment where I have millions of users watching or streaming or doing something, maybe we should scale up. But that ebbs and flows. So maybe we scale back down when that peak of traffic exists or goes away. Always remember that users will always remember your bad experience. You know, and potentially if it's your first time using a service, you may not come back, right? Especially if you visit, think of a restaurant. First time you go, the food was horrible. Do you ever say like, hey, let's go back because this is gonna be great, right? Most of the time you're tepid, you're very limited to going back. Same thing applies for the services that we write, ultimately the websites that we support. So with all those things in mind, in 2021 we said that enough is enough. We're gonna do DevOps. We're gonna formalize it, we're gonna build it, we're gonna grow it. If you see my past talks, I always talk about like the steps to building a landscape. And, you know, picking your environment, we did that. We have our source control, we have our CI, we have our CD. The tools are great. Look at it. Terraform. I'm sure someone's talking about Terraform today. GitLab CI, I've seen blog. I saw a tweet yesterday about that. Oh yeah, look, Google Cloud. Cool. Kubernetes, or, you know, serverless. We got it. Well, we forgot about one thing. Our developers. What's their experience? We had a bunch of tools here. Do we just give them Terraform? Why am I going to give our most senior .NET developer an interface to basically just write Terraform all day? that just really doesn't build a good practice, right? Like, and it also kind of leaves like a bad taste. You're kind of like battling your code, then battling Terraform YAML, and then going to HCL, right? So let's kind of walk through what was kind of going on to kind of visualize it. We had an issue of environment overload. So we'll start off. Non-prod, prod. Most likely how we started. Spoiler alert, we have a lot of developers. So they're all trying to get their changes in. And they're always stepping over one another. And more importantly, we have a QA team out there saying, what am I testing exactly? This non-prod environment? You know, they're trying to figure out whose merge request made it in and how they got there and when should I test. And ultimately, it would lead to times where the deployments were either slow or we had to lock down environments to have QA to have a solid testing environment. So DevOps did what we did. We had Terraform, right? Another environment, UAT. So now our QA team's happy. They got a nice little testing environment. They can lock it down wherever they need. Developers can keep developing. And we had our production environment. And that was great until it wasn't, where a developer pushed the prod issue. And then ultimately, it was a doctor's problem. And, limited understanding of how to debug this, multiple doctors had that problem. So we're just pushing fixes and pushing fixes. So then we said, you know what? Let's create another environment. This time we'll call it Stage. Yes, it's called Stage and it's in production. Don't worry, that's another story for another day. So we have this environment. Now we have one or two, a select handful of doctors that we test and experience with before we roll it out. Or you could argue that this should be a called canary. And that's great. Until you start, their APIs in production, so other people start to consume those APIs. One service is not a problem. Don't worry, it's not just two services, but let's just assume a lot of services start hitting it, and now, internally, you're also causing a problem. Other consumers and other dev teams. So, spoiler alert, DevOps, let's create another environment. And now we have this data environment. No more environments, this is it, we promise. This is it, no more. So the DevOps team kind of felt like this. We're just laying the road in front of us as developers are adding new features. We had the tools, we had the technology, but we really didn't have that entire developer experience. How do we tie this all together? And thus, the rise of platform engineering took a hold. So at this point, we had to recognize all the hard work we did. Look, the tools that we had and everything, it worked. It totally worked. We were building infrastructure, people were able to deploy, but you always have to ask, what else can we do to get better, right? So we had GCE VMs in Windows. We had Cloud Run and Cloud Functions, containers and serverless. We even had support for COS, container optimized images in Google Cloud. We still were in a position where developers are figuring out the implementation details. To scale your app, go talk to DevOps. They controlled your infrastructure. You wanted to open another port. DevOps was the one in charge. IAM, our security teams, along with DevOps, had to figure out what policies to add, and a lot of times, those were handled behind human requests. Hey, my app needs this. Our technology and our deployments, especially with tools like Spinnaker nowadays, are deploying hundreds of times a day. So there's really no time for a human delay. Debugging, legacy Windows debugging was painful. If I have to install like perfmon or like the power tools on Windows one more time, I'm gonna scream. Inconsistency. We didn't have that developer experience that we talked about earlier. So dev teams were essentially making their own pipelines. And importantly, since it lacked integration, teams like our data engineering team ended up building their own experience on how to do database migrations. So instead of having a one seamless experience for our developers, they had to deploy their app, migrate their database, redeploy their app. It was essentially hopping around different teams and more importantly, different pipelines. It was confusing. So we had to evolve DevOps as well. So DevOps now is taking a stronger shift into cloud engineering principles, focusing on building a best-in-class infrastructure. But more importantly, providing various tools to help accomplish those. So like managing our Spinnaker environment, managing how our GitLab CI environment's running, and figuring out how to connect those dots. We took a strong investment in building a delivery engineering team. So this delivery engineering team is connecting those dots of those tools, connecting those tools that don't necessarily piece well together. We have Terraform, we have GitLab, we have Spinnaker, we have Bugsnag. How do we build a nice unified story? So a lot of the tools are built together in code. How do we standardize the data that flows between these systems? How do we create a reliable metadata that goes throughout from a commit all the way to your deployment? And ultimately, like I said earlier, how do you work alongside DevOps, transforming that rock solid, awesome infrastructure to a developer-facing tool to build a good developer experience? At the end of the day, both teams are charged with building compelling solutions that are simple, minimize context switching, and provide accurate and fast feedback. We always ask ourselves, will this empower our engineers to take action, fix the problem, or fix the quality of life of their release process? And at the end of the day, just tied together to build that platform experience. And this is why I always say things like, an effective delivery pipeline rarely starts with delivery. There's a lot of things that go into building deliverable apps. First off, not to be corny, but it does require teamwork, right? I mentioned earlier, our app was .NET 2. That's like when I graduated college. Like, that's Jesus. Like, it's old. So, and it's also running legacy Windows environment. So how do we get there? It was a lot of migration and a lot of pain and effort. And also, the database migrations had to kind of go alongside with that. So teamwork, it's good. It's good. Be nice to your coworkers. Culture of empowerment. I always debated using this image because I'm tired of it, but developers, what are you doing to shift left? It's easy to say you shift left, but what does that mean in your organization? What are you giving your developers to not only build the right tools, but also help them? We don't just give our developers YAML. I mean, you can, but that's how you cause outages, right? Because we all make mistakes. We want to provide them guardrails, not gates. And that's where you transform your existing teams, like your networking team, your DevOps team, your security team, as subject matter experts. Hey, I have to make this app available on the internet for the mobile endpoints. Help me get there. Networking can sit down, talk about the ingress controllers and what you need to do. Security can verify your app, do some pen tests, make sure you're deploying secure stuff. How do you connect those dots and be points of reference for your developers? Define a simple goal. For us, it was easy. Click of a button. We want to click a button and magic should happen. Obviously, there's a lot of work that goes behind that click, but as we know, make it simple. And ultimately, centralize and build around a common delivery platform. And in our case, spoiler alert, it was Spinnaker. So, I always like to ask this for frame of reference. How many folks in this crowd are new to Spinnaker? Okay, cool. A lot of people know it, so that's good. But regardless, whether you're watching on the stream, if you're new, welcome, and we're happy to have you here. It's a great community, and thank you for taking time out of your day and watching this talk. So, a little bit about Spinnaker. It was created at Netflix, and it was battle-tested by many. It's an open, active, and growing community, as you can see here today. We have a lot of great companies using it and growing the platform from where it once was. And it's growing. But more importantly, there's still, like, the beauty of Spinnaker is that it supports not only from a community perspective, but it also has, like, partner engagement. So if you need that professional services, love, and attention, we have folks like Armory and OpsMX who are graciously here today. It supports multi-cloud. So it supports Google Cloud, Kubernetes, AWS, and other providers. It enables you to create automated release processes, leveraging CI/CD event triggers in your pipelines. There's a ton of them. I'm not going to go into that today. And ultimately, now that it's backed by the Continuous Delivery Foundation, we kind of have a little bit more backing in terms of a bigger community. So it's great to see the project go from, essentially an open source repo at Netflix to, where it is today. Very impressive. For us, it made sense. We looked at our cloud landscape. We were EC2, Lambdas, some GCE, well, majority GCE, and we wanted to go towards Kubernetes, right? And it allowed us to do that. This is just kind of a sample, but in this environment, we have our EC2 instances on the bottom, and right on top, that same deployment going to our Kubernetes cluster. There's nothing really kind of going there, but it supports multi-account, multi-region, and multi-cloud, so it made sense for us. We found that the pipelines allowed you to create a visual, simple step for each item in that pipeline, that performed complex operations, but ultimately the pipelines were just JSON, pipeline templates and stages. So what that meant is that after a while of kind of going in the GUI and clicking and dragging and you learned everything and you had your ideas, you could take those and basically build templates out of your pipelines. A lot of companies do this. They have their internal pipeline templates that they manage and deploy today. But in short, you could take those and edit as JSON and then create essentially a pipeline, and they could replicate that for each of your applications. So that was a big win for us. You know, Spinnaker always is talked about as a software delivery tool, which at its core it is. But I think the biggest thing is that it allows you to lay out your business process, especially for people who may not be tech experts, or rather learning this new world, right? They may not understand how you're triggering their tools, but if you could show them in one view where they sit in that flow, it gives them confidence that you're not working around them or you're skirting the details, right? It's easy to roll fast. It's easy to deploy fast, but you should always consider your rollbacks and how you move forward. A lot of folks in the crowd know this, but basically a flow, Git to some build endpoint builder, in our case GitLab CI, Docker registry, trigger Spinnaker, deploy YAML, go to Kubernetes. That's kind of like a standard, simple flow. There's a lot more complexities you could add to that, but that's where it is. So with Spinnaker, we're driving solutions now and in the future, and that's something that we really valued when we're making our decision as to what to use for our delivery platform. The first of which, we asked ourselves, what's missing in our current deployment flow today, right? So Spinnaker's main bread and butter is, well, deployments, right? That's at least how I always think about it. But even within that, you gotta remember there's a lot of, it's not just deploy my container, there's a lot of strategies behind it. Whether you're going into blue-green, you're doing Highlander where you just don't care and you just wanna roll forward. Do you wanna do a weight-based rollout? Do you wanna do a canary-based rollout? There's a lot of things you have to consider, and does it support all the things that we want? Many companies may not need this, or it may change on environment, but can I do an approval? Simple things like this give people context, especially when you're looking at compliance, which is something in the healthcare industry we have to do, tracking that someone authorized this change and keeping a record of that. That record, that approval propagates through the pipeline, so you know who clicked the OK button. What about integrating quality and testing? You know, I said earlier, our testing and quality was manual at the time, but now they're investigating in test suites. There's a whole slew of things that you could do in that world, whether you're doing something as simple as Postman or using an off-the-shelf tool like Locust. But there are some simple things you can do to do some performance testing, as well as API testing, or ultimately writing your own framework, which is a big endeavor and it should always be taken with some thought. What about including security automation, right? You know, pen tests don't have to be ad hoc. I would love to know when I introduce a security vulnerability at the time I introduced that vulnerability versus ending up on the front of a blog or a Reddit article saying how we hacked you. Consider integrating database migrations, right? I've seen many organizations do things like liquid-based migrations before they deploy. I talked about it earlier. Our database team built their own pipeline. What about bringing them into the fold? It may not always run, but it's there. I mean, it may not even be needed in every pipeline. Does a UI pipeline need a database migration? No. Change control, right? I talked about it. You know, I'm not discrediting it, but I think it has to be evolved into the world that we're deploying fast. So out of all these operations, at the end of it, what's the harm in sending all that data somewhere? In our case, it's a simple Jira ticket. It's an API for it. If you want to be nice, write an API and decorate it and put some nice little colors and links out to various providers. It's always, you know, because again, that flow of metadata. And then ultimately, like, what about your SRE teams, right? The dashboards and metrics are standardized. I talked about that earlier. Try and keep things as homogeneous across your applications as possible. But if you truly are emitting kind of the same metrics, we're .NET 6, we're running in Kubernetes. Most of the time, 90% of your metrics are probably going to be the same. What's the harm in just giving them a basic dashboard? Hey, whether you use it or not, here you go. Here's a free Grafana dashboard. So at the time, Spinnaker and Kubernetes, we had to make a decision. We put a lot of work, 3 years, into our VM stuff. And we wanted to build net new, right? There's a lot of questions, right? Kubernetes, we always see things, we always see the canary demos out there. We're like, oh yeah, but those are small microservices. I can't do a monolith in Kubernetes. Well, has anyone tried? So in addition to that, it was also confusing, right? Does anyone remember like the first time, like, I'm sure everyone in the crowd's probably, done their tutorials and stuff, but remember that first time you made a Kubernetes YAML and you're like looking at it and you're like, what the hell is going on here, right? Think of that moment in a world where you went from building infrastructure manually or creating in Terraform to translating that, right? How do I even make a DNS record for a Kubernetes service, right? Spoiler alert. We took a holistic view at Kubernetes as to what it could automate for us. And for us, we saw DNS. It could be automated with something like external DNS. Those certificates that we were chasing either GoDaddy or some random cert provider that we had and had to go email and go buy, maybe we can use Cert Manager, run our own certificate store. Secrets management, because we all know that Kubernetes does not encrypt your secrets by default. It encodes, so make sure you encrypt those secrets somehow. How do you load balance and route? Well, Nginx has an ingress controller. You can use Istio as a service mesh or others. There's great ones. I just put Istio because that's the one I'm used to. It doesn't matter. There's a lot of great offerings out there. At the end of the day, we started small. I always like to say, don't let perfect be the enemy of good. I didn't say that. That's Voltaire, but that's a good phrase to keep in mind. Constantly improve. Let's take the case of that app earlier. We knew where we wanted to go. Microservices, we hear about it. .NET, Python, Kubernetes, that's the dream. But sometimes it's like a bad nightmare. The monolith, .NET, Windows. How do we tackle this, right? So do we just start trying to wait for this to be done? Or do we figure something small? So for us, it was easy. We had a website migration. Most of it was running on WordPress. The web team was deploying it to, I believe, S3 at the time. I said, hey, do you want to deploy it into Kubernetes? Not the ideal state, because at the end of the day, you should be using static hosting for your static websites, but it gave us a simple way of proving out that, can we create a Spinnaker pipeline? Can we develop that YAML to deploy? Because if we keep a agnostic approach as to what we're deploying, where we're not building .NET specific things into the pipeline, we can then service any language that we have in the company. Whether you want to write in Rust or you want to write in Python, we should be able to support you. Going back on that, the biggest thing though here, honestly, was that it won support from our business too. Because a lot of folks get scared that you're moving infrastructure and they saw how long deployments took before, but then business users were able to go into meetings saying, hey, how long will it take to add the logo? And by the end of the meeting, you were able to add that logo. People see the value, and that's a solid win for the business, or the folks on the business side. So at the time, we kind of came back to our developers saying, hey, how are you doing on that Linux migration from .NET? I had to generate this GIF, because somehow they moved the monolith. Once I think they saw Kubernetes and how fast the web team was going, they somehow moved the .NET app in like 3 months. Like, I'm like, holy crud, like how much, you guys are sleeping, right? You folks are sleeping. It was an impressive migration, but we essentially enabled a highway to migrate your apps. We had our monolith running in the cluster, but then we also built a path for them to migrate out their microservices. Hey, /patient no longer goes to the monolith. Build an ingress route and go to that patient microservice. Leveraging something like Istio, we were able to canary critical components of our application in our payment API, which ultimately makes how we get paid. So we want to make sure that that works. And then that can extend past, that model can extend past to all your various subcomponents as well. But again, at the end of the day where we're at, we're not just going to give developers YAML. I like this quote that one of my team members said is, I could see how Kubernetes makes onboarding super simple, because he saw it. You create it, it creates your DNS record, creates your certificate, but then again, typos suck. And Kubernetes is super unforgiving. Nothing stinks more than having to debug a line 38 YAML, and then you find out, oh, oops, I missed a dash, or oh, it's not in the spec, right? I always like this is like us giving developers YAML. We don't want to end up in the same situation as we started this whole thing, where we put the burden of implementation details on our developers. So, with that in mind, where are we going? We wanted to provide paved road for our developers with golden templates. Now, whether that's in Helm or that's in GitLab, we want to make it simple for this is how you build your code. This is how you deploy your code. And more importantly, if we can automate that. We're looking at building a growth on a tool that we open source, that we've been a big open source contributor in Formats, but essentially provide our developers safe defaults with customizable templates and enforce overrides. Developers can tell us what they want, and we build those pipelines and that infrastructure to their spec. And if it doesn't allow it, we can then have a conversation. Like, for example, maybe we restrict how many public websites you can have, right? We limit, like, hey, public needs to have some discussion. We want to look at things like service mesh to enable that canary header, right? Maybe traffic goes to prod, and if you have some specific header, you go to another cluster or to another environment. Deployment inside the cluster. So something like service mesh. Again, service mesh doesn't have to be SEO, just use what you're used to or what you would like to invest your time in. Leverage and grow canaries. I mentioned it earlier, but canaries are no longer an environment, they're a feature of your environments. So you can have a stage environment, a development environment with canaries in flight. You know, think of the world where a developer is building a piece of software. They're iterating, and then when they merge to mainline, that's when you make your modifications. Want to build a sophisticated strategy around how we do multiple canaries as well, and spoiler alert, how you clean those up, because we don't want to just leave pods running in our cluster. And then ultimately measure performance. Again, not to say Spinnaker can solve everything, but Spinnaker does have something in Kayenta. So it is worth something that we should be looking into, whether it's, fits us or not. We want to visualize our performance. So this is kind of some live traffic from our deployment, but we want to give those tools to our developers so they can see whether deployments are working or not. This is a tool called Kiali, but it's surfaced through tool metrics in Prometheus and OpenTelemetry, and then ultimately giving them that Grafana dashboard that I talked about earlier. Again, shifting left doesn't mean you just put the onus of operating the tool to your developers. You give them the tools to make those calls, to set those alerts, to essentially debug their application, give you as much context. When they truly call you, they really need you. You hear it a lot, but we want to look at maybe simplifying a lot of this with our internal developer portal. Like today, you create a repo, then you got to go find how to do your code. Maybe if you're good, you don't need that. CI, what CI steps do I need? What CD steps do I need? All right, I'm going to bookmark the Grafana dashboard. I'm going to bookmark, you're going to hunt and peck in the Google Cloud Console as to which project you deployed to and where your logs are sent to. Whereas here, in the future, to get started, you can go to a portal, select from a list of predefined apps like, hey, I'm a .NET 6 app that's going to go to GCP GKE. You click it, you give it a name, maybe it provides you some suggestions, and ultimately, your repo is created for you. Your CI/CD is created for you. More importantly, all those things that I talked about, your health and performance, are linked to there. Whether they're integrated or not, at least you get helpful links where you can just have one experience to see the life cycle of your entire application. And if you want to be nice, even provide things like docs. So, a lot of talking. Let me just put it all together. The key takeaways, first off, is understand where you are, how you got there, and where you want to go. So I talked a lot about like the roadmap as to, the manual, to like kind of the DevOps, to like now the future of like delivery engineering / DevOps. Tools at the end of the day should be unified to build an experience, right? They shouldn't define your experience. Build a culture of education and empowerment for your engineers. Again, I really strongly feel that your tech teams become subject matter experts to what you're talking about shifting left. We say shift left, developers. You don't just give them the tools without any help. Provide those developers and engineers guardrails, not gates. Give them the safe default. At the very least, you can get into the production, and then you can cascade. Maybe you can't deploy a public app, but at least you can get into it as an internal app, and then we can have that discussion as to how to expose it. Make your pipelines bring complex processes and teams together. Again, showing how all those dots had different teams' ownership behind it. It builds a conversational flow as to when that dot turns red, they can go talk to the security team. It doesn't always fall on your DevOps team. Build and empower those teams as well to become more. And hopefully out of this, you learn that Spinnaker is awesome. So shout out, we do have a tech blog where I talked a little bit about how to get started with Spinnaker Operator on GCE or GKE and IAP. It's a pretty big article. Again, they mentioned earlier just to talk about how you install Spinnaker, so this is how we install it. So if you're interested at all, check that out. But regardless, thank you so much for having me. It was truly great to be back after a long time. So thank you, everybody.